Imagine a universe where the past, present, and future all exist at once. A place where every moment, every event, and every experience is eternally preserved in a cosmic tableau. This is not a science fiction fantasy, but a profound concept in theoretical physics. This is the core idea behind the block universe theory. According to this theory, time is not a river that flows from the past to the future. Instead, it is a vast, unchanging block where all points in time coexist simultaneously. It challenges our everyday understanding of time as a flowing river. We are accustomed to thinking of time as something that moves forward, carrying us from one moment to the next. But what if time doesn't flow at all? Instead, it proposes that time is like a vast, unchanging block. Imagine a giant solid cube where every slice represents a different moment in time. Each slice is fixed and unalterable, existing alongside every other slice. Every moment in history, every event that has happened or ever will happen, is a fixed point within this block. From the birth of the universe to the fall of ancient civilizations, to the future events that have yet to unfold, all are eternally present in this cosmic structure. This concept can be difficult to grasp because we experience time linearly. Our lives are a series of moments, one following another, and we are always moving forward. We look back at the past with nostalgia or regret and look forward to the future with hope or anxiety. We remember the past and anticipate the future. But the block universe theory suggests that these perceptions are just our limited experience. Our brains are wired to perceive time in a linear fashion, but this may not reflect the true nature of reality. The past isn't gone, and the future isn't unwritten. They are both as real and present as the moment you are experiencing right now. In the block universe, every moment is eternally preserved, like frames in a cosmic film reel. They exist simultaneously in the grand tapestry of the cosmos. This idea invites us to rethink our understanding of time and our place within the universe. It suggests that our lives are part of a much larger, timeless structure, where every moment is interconnected and eternally present. To visualize the block universe, imagine a child's flipbook. Each page shows a slightly different image, and when you flip through them quickly, it creates the illusion of motion. Now imagine that the entire flipbook represents the block universe. Each page is a single moment in time, a snapshot of the universe at that instant. The entire flipbook exists at once, just like the block universe. We experience time by moving from one page to the next, but all the pages, all the moments exist simultaneously. Einstein's theory of relativity plays a crucial role in understanding the block universe. Relativity tells us that time isn't absolute. It's relative to the observer and their motion. This means that there is no single universal now that everyone experiences at the same time. Imagine two people, one standing still and the other moving at high speed. Time will pass slightly slower for the person in motion relative to the stationary person. This difference is called time dilation, and it's a real effect, not just a theoretical concept. Let's take the example of three spaceships moving at different velocities relative to each other. Each spaceship would experience its own now. One spaceship might be communicating with Earth's past, another with its present, and the third with its future. This might seem paradoxical, but in the context of the block universe, it makes sense. All of these nows are equally valid because time isn't absolute. It's relative to the observer's frame of reference within the block. Section 5. The paradox of choice, free will in a predetermined world. The block universe theory raises profound philosophical questions, particularly about free will. This theory suggests that the past, present, and future all coexist simultaneously in a four-dimensional space-time block. Imagine time as a loaf of bread, where each slice represents a moment in time. All slices exist at once, but we experience them sequentially. This raises the question, if the future is already there, do we genuinely have the freedom to choose our actions, or are we merely following a pre-written script? If the future already exists within the block, does that mean our choices are predetermined? This is a question that has puzzled philosophers for centuries. If every action we take is already mapped out, then the concept of free will becomes an illusion. However, some argue that knowing the future doesn't necessarily mean we're bound by it. Just because a map exists doesn't mean we can't choose our path. The debate between determinism and free will is a complex one with compelling arguments on both sides. Does free will, as we understand it, even exist? This question delves into the core of human experience and our understanding of autonomy. If our choices are predetermined, then our sense of agency is merely an illusion. On the other hand, if we do have free will, how does it coexist with a predetermined universe? Some philosophers suggest that free will and determinism are not mutually exclusive. This concept, known as compatibilism, argues that we can have free will even in a deterministic framework. This is a complex question without a simple answer. The debate touches on various fields, including philosophy, physics, and even neuroscience. Some scientists believe that our brains operate in a deterministic manner, governed by the laws of physics. Others argue that quantum mechanics introduces an element of randomness which could allow for free will. The interplay between determinism and free will is a rich area of study, with new insights emerging from different disciplines. Some argue that the block universe implies determinism, where our lives are prescripted and free will is an illusion. This perspective suggests that every event, every decision, and every action is already set in stone. From this viewpoint, our sense of making choices is just a byproduct of our consciousness, giving us the illusion of control. However, this deterministic view can be unsettling, as it challenges our fundamental beliefs about personal responsibility and moral accountability. Others maintain that even if the future exists, we still have the freedom to choose our actions within the framework of the block. This view suggests that while the future is there, it is not fixed in a way that negates our ability to make choices. In this sense, the block universe provides a structure, but within that structure, we have the agency to shape our destiny. This perspective aligns with the idea of compatibilism, where free will and determinism coexist, allowing us to navigate our lives with a sense of purpose and autonomy. Quantum mechanics, the study of the very small, delves into the fundamental nature of particles and waves at the atomic and subatomic levels. It challenges our classical understanding of physics and introduces concepts that are both fascinating and perplexing. This field introduces another layer of complexity to the block universe, a theoretical model where time is viewed as a dimension similar to space. In the block universe, past, present, and future coexist simultaneously, creating a static, unchanging structure. However, quantum events, like the radioactive decay of an atom, are inherently random. These events do not follow a predictable pattern and can occur at any moment without any apparent cause. While we can predict the probability of these events occurring within a certain time frame, we cannot determine the exact moment they will happen. This probabilistic nature is a cornerstone of quantum mechanics. This unpredictability challenges the notion of a completely deterministic block universe. If quantum events can introduce randomness, then the block universe might not be as static and unchanging as previously thought. This randomness suggests that the block universe might not be completely static. Instead, it could be a dynamic entity, constantly influenced by the random occurrences at the quantum level. These quantum events could introduce tiny variations like ripples in the fabric of the block. Just as a single droplet can create ripples that spread across a pond, a single quantum event can have far-reaching effects. These ripples can cause minor disturbances that propagate through the block universe, potentially leading to significant changes over time. Just as a small change in initial conditions can lead to vastly different outcomes in chaotic systems, these quantum-induced variations could cascade into larger differences over time. This phenomenon is akin to the butterfly effect, where a small change in one state of a deterministic nonlinear system can result in large differences in a later state. This adds an element of unpredictability to the seemingly predetermined nature of the block. The interplay between determinism and randomness at the quantum level creates a universe that is both ordered and chaotic, predictable and unpredictable. It is this delicate balance that makes the study of quantum mechanics and the block universe so intriguing and endlessly fascinating. Imagine the now as an uneven, constantly evolving surface within the block universe. This surface represents the present moment, the point where the past and future meet. But unlike our usual perception of a flat, uniform now, this surface is dynamic and ever-changing. As new moments are created, the now surface expands, constantly moving forward within the block. The shape of this surface is influenced by the relative motion of observers and the random fluctuations introduced by quantum events. Some physicists believe that time, as we experience it, might be an emergent property. Just like temperature arises from the movement of molecules, time might arise from a deeper level of reality that we don't yet fully understand. This idea is still very speculative, but it offers a different perspective on the block universe. Perhaps the block itself is timeless and time only emerges as a property within our specific level of reality. The block universe theory, while challenging, provides a fascinating new lens through which to view time and our place in the cosmos. It encourages us to question our assumptions about the nature of reality and to consider the possibility that the past, present, and future might exist in a way we never imagined. While it doesn't offer easy answers to questions about free will or determinism, it opens up exciting avenues for exploration in physics, philosophy, and our understanding of the universe and ourselves.